So we got to this level until the last video. So as a result, the limit ln mgf of s, which is scaled value of x bar, and it equals to this form here. So still we need to get this value to calculate. But we can actually get it easily by thinking about the variance. So thinking about the definition of variance again. So variance of x, which is like random variable here, equals x minus expectation x and is squared, right? So let's put it like m here. So it's going to be x minus m and is squared. So we can write this something like mx plus m squared. So by the linearity of expectation, we can divide it like this and like this, right? And like this. And this is m. So it's going to be like this. And finally, we'll get this as a result. So it was a like variable we randomly decide to use, which is x here, but we're dealing with z here, which is the standard normal distribution variable. So we put c here to c because we need this form, which is this, and z squared. And we know that z follows normal distribution, which has mean of 0 and standard deviation of 1 because it's standard normal distribution. Then it is 0 because it's the mean of z, so it equals 0, so it's gonna be disappear. And the variance of z is the square of the standard deviation, so is 1 squared, which is just 1. So we can conclude that expectation of z squared equals 1, which is the thing we need here. So we can rewrite this as t times 1. So it would be t squared divided by 2. This is the final form. And you remember, like a long time ago, we actually proved or got the MGF of x when x just follows normal distribution, which has mean as mu and standard deviation as sigma, and the MGF goes like this. So when we want to get the MGF of a standard normal distribution, then all we gotta do is put 0 and put 1 into each parameters, right? So we do it here, and we put here 1, so it's going to be 2, and 1, and this is 0, 0. So it's going to be like this. So this is the MGF of standard normal distribution, and it's exactly the same form as here because we have log here. So we can actually rewrite this. So when n goes to infinite, t becomes like this. So this is the final form. So we know this because by just scaling doesn't actually mean anything about the distribution. So we can see that the MGF of s, which is the scaled value of x bar here, and actually this x and this x are different. It's just random variable, to just show the this form. So anyway, so now we prove that the MGF of scaled value of x bar, and when we increase the n to infinite, which is large enough, the MGF result goes in with the MGF of standard deviation. Standard normal distribution, I'm sorry. So we can conclude that x bar, when n goes large enough, x bar and its distribution follows normal distribution by this long proving. So thank you for watching, and finally we're going to deal with the confidence interval from the next video. Thank you.